Hello everyone, welcome again to another edition of Data Analytics or Analysis with Last Swift Data Analytics. Today we are going to go through a template created for carrying out PET t-test. So a PET t-test is a statistical test that is carried out to measure the average means of two different scenarios or two different data sets. Sometimes they are referred to as the before and after data. So PET test has a couple of applications in every real life situations and in big industries in like mining, in business, and in health, also in sports as well. Basically, if you want to know the if you want to make a business critical decision, you need to carry out this test to say and determine that one approach is better than the other one. So without further delays, let's get through it. So this is a template we've created already, so we'll just go through it. So these are the examples of the applications of PET test. One is in business. Basically, you want to compare the revenues generated in first quarter versus the revenues generated in second quarter. You can carry out a PET test. In health, just an example, your cholesterol level before and after you go on a diet. So you can measure your cholesterol level before you go on a diet, and you also you measure your cholesterol level after you start going on diet and doing some physical exercises, and then you run your PET test to see if the average the difference between the average values for these two scenarios is significant or not. An example also in the mining industry is you compare the recovery of your metal, for example copper, when you use the old chemical or old collector, and you compare the recovery also when you use a new collector. So you compare the recoveries of copper under two different collector types to see if one is performing better than the other, and then you can make a business decision to select which type of collector to use. Before you do your PET test, there are a couple of things that you must specify. One is your confidence level. Your confidence level, basically your confidence at which you want to report the findings for this test. Secondly is your hypothesis. Your hypothesis comes in two categories. One is the null hypothesis, the other one is the alternative hypothesis. So these two hypotheses are like inferences that serve as a criteria for your test. Okay, let's get to it. So this is the setup of the template. There are two things that you will have to do since everything has been set up for you. One is you put your data here, the before and after data for whatever situations, like your business or for your education or your whatever applications that you are trying to carry out the test for. And two is to specify your confidence level. All you have to do is you input these two data, and since it's a template, it will populate a result for you, the statistical result. Or response for you in this table here, this outlook here, and it will also populate a dashboard for you. So at the end of the test, all you have to do is present this dashboard to the management or to whoever concerns. Okay, let's get to it. We'll use an example here to run the test. So as an example, we will look at an academic situation. So our scenario is we want to run the PET test for students in grade 5, subject is mathematics for term 1 and term 2. So the scenario, term 1 and term 2. So let's just assume that in term 1 they have a different maths teacher, and in term 2 there's another teacher. So we want to see if their performance has improved or dropped when they change teachers. So we'll copy this data, we go to our table here, we paste the values here, and let's report or carry this test at 95% confidence level. So like I said, since this is a template, everything is set up, so voila, here are the results from the test. So basically, if you look at the results, the mean value, the mean score for this data set is around 18.4 points, and that of the other data set is 20. Observation is 20, meaning 20 data points. If you count down, there's about 20 of them, 20 students in the class for this case. You have your standard deviation here for the two different data sets, also your variance. Basically, this is the square root of this is the square root of the standard deviation squared value. Also, you have your critical values and your p-values or your probability values, and your standard error and the standard error of the difference between the two values, two data sets. So here is our results. So from this result, we have seen that our null hypothesis has been rejected and the alternative hypothesis has been accepted. So what are these hypotheses? So if you look at here, look at this table here, our null hypothesis is saying that the average, the difference between the average values of the two scenarios, basically this one and this one, the difference is 0, meaning that for this case the students, the performance did not change, it did not improve or it did not drop. This is what the null hypothesis is saying. That's criteria 1. The alternative is obviously the opposite of this one. So it's saying that the difference between the average values of the student performance under two different teachers is not equals to 0, meaning that it's either a positive value or a negative value. So after having run through after having run in the test, our result here has rejected this hypothesis and it has accepted the alternative hypothesis. So that means that yes, the difference between the average values of the student performance under two different teachers is not equals to 0. So as stipulated, the mean difference here is a positive 2.05 points. So what this means is there has been an improvement when the new teacher comes in. So basically a positive value means that there has been an improvement, improvement by 2.05 point on average. So basically if you look at it, you can see here that the pre-data is 18 for one particular student, and after the new teacher comes in, the points went up to 22. It's the same the same outlook is given here for the second student. In term 1 the student scored 21 in a test, and in term 2 under the new teacher the score went up to 25. So on average the students are performing better under the new teacher in term 2. That's what is saying. I'll just open up this background calculations here for you to have a glimpse. So this is what's happening at the background. Since it is a template, it's been set up already. So we have applied a custom formatting here. That is why you see emojis of smiley and sad emojis, not numbers, because of custom formatting. And this one here is a conditional formatting. So let's head over to the results, the final dashboard, result dashboard. So this is the result here. Okay, one thing I'd like to point out is these two curves here. Since they are pivot charts, in order for the pivot charts to display the graph, we need to refresh the pivot table, because they are getting the data from a pivot table, which is in this sheet here, the normal distribution sheet here. So at the moment it's indicating that there's been an error or something. So the reason why it's indicating this one is because this data was empty, and then we copied and placed the new data here, so it's yet to pick it up. And it will only pick it up, or it will only reflect that once we refresh it here. So you click on this one, you go on to this pivot table menu here on the ribbon, and then you click on this icon here, the refresh icon. Once you do that, okay, it has loaded all the data in this table here. So it's loaded here, so now your results should pick it up as well, the pivot chart. Voila, here it is. So this is your average values, and this is your normal distribution curve for the two scenarios. Basically, before is for term 1 for this case, the old maths teacher, and after is for term 2 under the new mathematics teacher. So if you look at it, the result has been interpreted for you because we have input or inserted conditional formatting, so it's interpreted already. So it is saying there has been an improvement when the new teacher came in, and the improvement is by 2.05 points. Now the reason why we say an improvement is because the difference is a positive value. If it is a negative value, then we would say that when the new teacher comes in, the student performance dropped. And by how much is this value here? If it's a negative value, then we will say that the student performance dropped by 2.05 points. So we are 95% confident that the new teacher is performing better than the old teacher. So this information is vital for the headmaster or the principal. So you might want to look at retaining the new mathematics teacher, because the students are performing better when he comes along, the new teacher comes in. So on average, you see, when the old teacher was teaching, the average score for the class, the grade 5, was at 18.4, but when the new teacher comes in, it had improved by 2.05 points to 20.5. That is the improvement. Okay, so that's about it for today. One thing also I would want to point out to you is this is a template. It's already set up for you to do it manually. There is also a tool in Excel called a data analysis tool. If you can also run this test there. You just have to go up to data tab on the menu on the ribbon, and you go to data analysis tool pack here. You click on it and you just scroll down to this one here, t-test pet2 sample for means, and it will basically ask you to select your data here, and also your confidence level, input your confidence level and whether you want the data to be displayed. So it will give you something similar to this one. So you can always do it using this tool pack here, or like how we did it here, as manually you have to do it yourself. One thing also I would like to mention is this one here. Our data table here is an Excel table, meaning if your data points is more than 20, for this case is 20, observation here is 20, meaning there are 20 data points. If you count down the column here, there's about 20 students. So the benefit of using this Excel table is if your data points is more than 20 or less than 20, it will adjust. This table will adjust on its own and it will not affect the calculation. So you don't have to like manually drag it down or up if for some other cases where you don't have an Excel table. So basically this is it. Again, thank you for your time, and I'll see you on another edition of Data Analytics with Last Swift Data Analytics. Bye for now.